following structure has been drawn without any formal charges indicated. And so what we need to do is correctly label any atoms in this structure that should have a formal charge. The easiest way to identify atoms that should have a formal charge are by looking for atoms that have an unusual number of bonds. So we know from what we've learned that usually nitrogen has 3 bonds, oxygen has 2, and sulfur also has 2. We can't really make any comments on any of the carbons in this molecule because they all appear to have a correct number of bonds, which is of course 4. But when we look at this structure, we notice we have a sulfur here that doesn't have enough bonds. We have an oxygen that has too many bonds. We have a nitrogen that has an extra bond. And we have an oxygen that's missing a bond. So formal charge can be calculated based on the number of electrons the atom is supposed to have. And so in order to do that, we take its valence electrons and we subtract non-bonding, and we also subtract the bonding electrons divided by 2. So if we start with this oxygen up here, oxygen has 6 valence electrons. We can see here it has 3 lone pairs, so 6 non-bonding electrons, and it has 1 bond, which means it has 2 bonding electrons. So 6 minus 2 divided by 2 gives that oxygen a formal charge of -1. The nitrogen next to it, nitrogen has 5 valence electrons. We subtract out the number of non-bonding electrons, which in this case is 0. And then we see that it has 4 bonds, therefore 8 bonding electrons divided by 2 gives us a plus charge on that nitrogen. The sulfur here is going to be exactly the same as what we saw for the oxygen. Sulfur has 6 valence electrons, minus 6 non-bonding, minus 2 over 2 bonding, gives us a charge of -1. And finally, this oxygen has 6 valence electrons, minus 2 non-bonding electrons. It has 3 bonds, so that's 6 bonding electrons, divided by 2 gives this oxygen a charge of +1.